So it's about a project called FoodManufuture. And this project was finalized in December 2013. And the idea was to design a food manufacturing research infrastructure. Because, I mean, foods at the end need to be produced, and you need to do it in a sustainable and effective way. And there is a lot of innovations that can come up from this production. So the project was coordinated by Elisabeth Mungårds in Denmark, but unfortunately she couldn't be here today, so I'm presenting the project for her. So the basic idea of this project, in fact, started as a collaboration between the European technology platform, Food for Life, and a similar platform that there is on the manufacturing side. And we found that if we join forces together, we could get a lot of inspiration from both sides. We could inspire the people from the manufacturing side to give more attention to the food sector and develop new equipment and new technologies. And at the same time, they could also inspire the food researchers about what the possibilities are. And in this way, I think we could achieve interesting and innovative infrastructure. So, I mean, the project and the approach was, I think, very similar to what has been presented today. We start by defining some kind of scenarios how food production could be done in the future. We have made a lot of mapping about what are the challenges of food industry nowadays. We have also looked at possible solutions that are available but maybe not completely used. And of course, we have also identified what kind of research infrastructures are available today and what capacities do they have. Based on this mapping work, let's say, we could identify gaps and what could be the needs for a research infrastructure in this area. Out of this, of course, we did model drafting and look at the different business models, how such a infrastructure could look like. We made a road mapping, and that became the output of this project. It was this design study, and which we call the food factory of the future. That's what we would like to inspire. So, of course, we did a lot of consultations, and in this work it's quite important to speak with the industry and the different stakeholders, and we did through a lot of different meetings. I don't have time to go into a lot of details, but just giving you a view. We look at a little bit at, in a workshop with the industry, a little about how food production could look like in the future. And I mean, there are different scenarios that can be, and some of them exist today. I mean, for example, one that foods are built based in ingredients that are combined, and foods can be personalized or formalized in some way. This is in some way done, but cannot be done more. We have also looked at these global microfood systems and global integrated in the chain. And of course, our food system will look like in the future will influence the kind of technologies and the scale up of the processes that you will need. So, as I said before, we did this gap analysis to look at capacities and needs. And I will just give you some examples of things that we got. And there is a very large material of about information regarding this mapping that is available on the web page if you want. But this is just some things that we found out, like sustainable food production, how you can take decisions regarding what kind of technologies are available is missing. Smart process design and process control, better way to control food processing. I mean, advanced food processing technologies. If you want to make different products, maybe the today's technologies do not allow you to do it. Of course, food hygiene, safety, quality are important. Shelf life is becoming an important factor. You want to extend shelf life. You don't want a lot of additives. There is issues here. And then, of course, innovation methods, and also, especially regarding with technology transfer, can be done much better. So just an example, because for each of these needs we came into more concrete detailed list about what can be included. And if I take this an example about this smart process control and ICT enabling manufacturing, I mean, there is need of virtual and design that you can do simulations before you start to produce foods, because you can speed up, for example, product development. I mean, ICT solutions are needed to optimize, for example, food supply chain, and this can reduce waste and many other issues. And I mean, and of course, logistics is still a major issue in food when foods are shipped back and forth. I mean, regarding the screening of the infrastructures, and here start a little bit what is an infrastructure. We have been also struggling how big should be. So we end up making a map like this, where we identify different infrastructures on food and manufacturing. Many of them at the time we were thinking maybe they are just elements of infrastructure, so they are not complete. So maybe they are just good in some specific areas, and they cannot really offer a whole solution. But you can see they are quite distributed, but the capacity in many is not good enough, or it's not wide enough to the needs of industry. I just put like this in case you don't find your point. You can go to the web page and registrate, because there is always a risk to put a map because someone is missing a point. But I mean, just a little bit to give some ideas. For example, in Berlin, they have at university a pilot plant basically for thermal and no thermal technologies. I mean, TNO has also activities, for example, for this 3D printing that is quite actual now. And INEA, for example, on energy and sustainable economical development. And there are other also from the manufacturing side, in this case marked in green. So out of this work, we define these research infrastructure gaps that we decide to prioritize them. So, and we had quite a big list. Then we decided to prioritize the 5 ones that our stakeholders found most important. And this is the list that we got. And as you see, come up quite up in the list, the need of pilot plants, more factory size, to develop new products that can be tested. I mean, there is quite a number of pilot plants, but as I mentioned before, they don't have full capacity. Many times you cannot produce the products that can be tested by consumers, and this makes that product development can be quite slow in many cases. I mean, if you want to look at new technologies, the capacities are even less available in many countries. So what we have decided was that these gaps we decide that we'll consider as needs of research infrastructure platforms. And that's the way that we build our concept, our future food factory, so that we have some kind of a hub that has membership of different companies and research suppliers, research institutions, but also having, for example, these pilot plants or these capacities. Then you integrate then in these research platforms. So it makes like a network. It's not so different from the one that you present. We have a little bit of different picture, but the different, for example, research institutions can contribute to their pilot plant, and this can be organized in these research platforms. And then we can connect customers around these research platforms, and in this way we can help, let's say, to come up to a more integrated approach and connect our activities. So a little bit what the 5 minutes, yeah. A little bit about the advantages. I mean, we want this future food factory to be industry-driven, to have these platforms dealing with the key topics that have been identified, should have this distributed location, because, I mean, we can still integrate things at European level, and as I mentioned, build on these existing capacities that you have today, because then you can make them much more effective if you organize them at the European level. I mean, for this infrastructure then will be open, broad, and will give access, for example, to SMEs also, and will maximize the use of capacities. In this way, I think we can offer cutting-edge technologies and facilities. I mean, we will avoid doubling the facilities, will be faster development of equipment, and also training. It's quite important, because then, since we will have these capacities, it will be more possible to have better training to industry. Of course, for the providers of technology, this will also be an advantage, because we can better optimize and exploit existing capacities, which today are not so well used because of lack of critical mass, for example. So, I mean, the outcome is this conceptual design report that is explaining in much more detail, if you are interested. It's available on the website. I mean, it's quite a big list about this identification of needs for the sector and the mapping that is being done that you can make available. And of course, as I mentioned, we identify what kind of research infrastructure elements Europe can use. And then part of this information is also at this iTech Europe database. And that's what I have to tell you. So, but more information is on the website if you want to look. Yeah. Thank you.
Thank you.